Okay, today we're going to start our Unit 2, and we're going to begin to start using video notes as a mode for us to get you the information that's going to become important. Today we're focusing on our angle problems and solving equations. The objective today, our students will be able to use vertical angles, adjacent angles, angles on a line, and angles at a point in a multi-step problem to write and solve simple equations for an unknown angle in a figure. So first we kind of have to get used to the language that we're going to use and the imagery that we want to think of when we see those words and vice versa. So adjacent angles are two angles, angle BAC and angle CAD with a common side AC with a little ray, are adjacent angles if C belongs to the interior of angle BAD. And if we come over to the diagram and we do a little bit of highlighting, essentially what it's saying is this ray AC has to be inside the angle, share the vertex, share the common side, and now angle A and angle B are vertical angles. So angle A and B are adjacent angles. Angles BAC and angle CAD are also adjacent angles. Next vocabulary word, vertical angles. Two angles are vertical angles if their sides form two opposite rays. If their sides form two pairs of opposite rays. And so basically what you're noticing is that from C to G and from C to F, those would be considered opposite rays. And if you do that for these intersecting lines, you'll see them form vertical angles. Defining vertical angles is really important to us, but also understanding that each vertical angle is congruent becomes a really important result as we work through the course. And so A equals B. The measurement of angle DCF equals the measurement of angle GCE. Okay. Angles on a line, you can go a little bit quicker. It basically means that as many angles as we have on a line, they will sum to 180 degrees. So the sum of the measures of two angles that share a ray and form a line sum to 180 degrees. So in our example, A plus B equals 180 degrees, and the measure of angle A, B, C plus the measure of angle CBD equals 180 degrees. A little aside to this, this works for more than two angles. True for more than two angles. So if, say, there was a third one, this is X, Y, and Z. They also would sum to 180 degrees. Finally, we have angles at a point. The measure of all angles formed by three or more rays with the same vertex is 360 degrees. Or in other words, A plus B plus C equals 360 degrees, or the measure of angle BAC plus the measure of angle CAD plus the measure of angle DAB equals 360 degrees. This just gives us the foundation so that we can begin to do our work together. And so you get to this discussion, and two angles AOC and COB with a common side OC are adjacent if C belongs to the interior. And sometimes what you need to do is draw a picture. Keyword being common side of OC. So I have AOC and then COB, and then OC would be your common side, and now we have adjacent angles. The sum of the angles on a straight line is 180 degrees, and two such angles are called a linear pair. Two angles are called supplementary if the sum of their measure is 180 degrees, and two angles are called complementary if the sum of their measures is 90 degrees. The way I remember that is sort of the alphabet. Supplementary starts with S, complementary starts with C. The number 90 comes on the number line before 180, just like C comes before S in the alphabet. So describing angles as supplementary or complementary refers only to the measures of their angles. The positions of the angles or whether the pair of angles is adjacent to each other is not part of the definition. So this is really, really important. The adjacent to each other aspect, which means the angles do not have to be adjacent. Angles do not have to be adjacent. So that's really kind of important. So your angles could be separate. All right, on to our first example. The two lines intersect. This gives us a lot of information. Immediately, two lines intersect tells me that I have vertical angles. And I know vertical angles are going to be equal. The ratio of the measurements of the obtuse angle and the acute angle in adjacent angle pair is the figure 2:1. In a complete sentence, describe the angle relationships in the diagram. The angle relationships are angles on a line. The reason why that's important is because when I have angles on a line, I know that they sum to 180 degrees. Setting up that equation, I can take my ratio 2 to 1. I can say 2x plus 1x equals 180 degrees. 3x equals 180 degrees. Divide both sides by 3, and x equals 60. But I haven't truly answered the question yet because I need to make sure they know that the acute angle equals 60 degrees. The obtuse angle equals 120 degrees. You may want to stop and pause just to catch up to the mathematics that I just did. Check your work and summarize what you've just seen, especially when dealing with the ratio, and set up the equation from the ratio. Okay. Our final problem is another ratio problem. It says 3 adjacent angles on a line. So again, the on the line part really matters because I know that they must sum to 180 degrees. So it says find the measure of each of the 3 angles and then draw a diagram to scale of these adjacent angles. So I found my find. I've annotated that on a line means the sum to 180 degrees. And so let's go. 3 to 4 to 5, 3x plus 4x plus 5x equals 180 degrees. This is 12x equals 180 degrees. Divide both sides by 12. X is equal to 15. Then I want to back substitute, so 3 times 15, 4 times 15, and 5 times 15. This equals 45 degrees. This equals 60 degrees. This equals 75 degrees. A little self-check. Does this sum to 180 degrees? So 45 plus 60 is 105. Plus 75 does equal 180 degrees, so it's a little self-check. You might want to pause, reflect on, again, how the ratio became the equation. And the last part says, indicate the measure of each angle. Did I do that? Yes. Okay, bringing out the protractor. We know we need to have our origin. Draw my line. And start marking off my angles. Here's 45. 45 plus 60 is 105. And so now here's my 45 degree angle, my 60 degree angle, and my 75 degree angle. Finally, some relevant vocabulary. We have adjacent angles, vertical angles, points on a line, and angles at a point. We also will want to include straight angle and vertical angles. So let me center this. You can pause, write down your definitions. And put those in your notebook. The last thing you really need to do is summarize what you've learned today. Thank you. Bye now.